Good morning, guys. Today we're going to be doing section 11.4, day 1. We're going to break this into 2 days. We're going to knock the bulk of it out today. I'm going to give you 3 problems for homework. And we're going to do 2 more tomorrow, and we will finish up the homework tomorrow. So what we got here is today we're going to do day 1 live for everyone out there, unless they're watching the video. Tomorrow we're going to finish it up, and then you're going to finish your 11.4, try it on your own. Wednesday is lesson 11.5. That is some applications of some rational functions. And we'll have that video for you, and you'll complete 11.5. Then Thursday, we will be working on the review. It's a live session for everybody, so you should be able to ask any questions you have. And between Thursday, Friday, Saturday, and Sunday, you're going to have to complete that review section, and you will submit 11.4, 11.5, try on your own, and the chapter review before you complete your chapter 11 summative, which will be on Monday, April 26th, and that will need to be completed and submitted by Monday night, and then it will close, okay? So please make sure you're organized and you get your stuff done. Well, all we're going to do here is these first 6 problems are really pretty much of a warm-up, and I'm going to refresh your memory here, and all you're going to do is you're going to find the domain of the function and identify any horizontal and vertical asymptotes. So I'll do number 1 with you quick, then I'm going to hit pause and have you fill out the rest of them. But number 1, we're going to look, and remember the domain, anytime our denominator can equal 0, we want to restrict that domain so it's all real numbers x except -3. And that is because that vertical asymptote is at x equals -3. And then when we identify our horizontal asymptotes, remember we're looking at the biggest power in the top and the biggest power in the bottom. And in the top we have an x to the 0 power because there is no x over an x to the first. Well, the power is smaller in the top than it is in the bottom, so therefore we will always have y equals 0 be our horizontal asymptote. And in number 2, I'll do that one with you really quick as well. So here we're going to see domain is all real numbers x except -3, because that x equals -3 is my vertical asymptote. And in number 2, I can see the degree of the top is the same as the degree of the bottom. So then we take the coefficient off the top term, which is -2, over the coefficient of the bottom term, which is 1. So our horizontal asymptote is going to be -2 over 1, or y equals -2. Okay? So I'm going to hit pause here, and I would like you to find the rest of these 4 problems. So in number 3, in order to find out what my domain is or where my vertical asymptotes are, I have to take that quadratic in the denominator and I need to factor it as I did, which means nothing reduced with the numerator there. So I have domain restrictions of 2 and 3, which means those are vertical asymptotes. And when I'm hitting my horizontal asymptote, I can see my degrees are the same on the top and the bottom. Therefore, I'm taking my 3 over my 1, my coefficients divided by the coefficients to get y equals 3. Number 4, yep, I can factor that bottom. There's a greatest common factor of x I'm going to pull out, so that bottom turns to x times 5x plus 3. So what makes the denominator 0 is when x is 0 or when x is -3 over 5. Again, notice, neither one of my purple factors reduced with my factor in the numerator there. Therefore, I didn't reduce anything out, so those are my vertical asymptotes. And my horizontal asymptote, well, because the degree of the top is 1, the degree of the bottom is 2, the top is smaller than the bottom, so my horizontal asymptote is y equals 0. And then I come into number 5 here. Well, number 5, again, I'm going to factor that bottom, x squared plus 9. Ooh, Kruger, you made a little boo-boo there, didn't you? Because that's not x squared minus 9. Ooh, it only factors if that's a minus. There's no factor there, which means there are no domain restrictions because there's no number I can plug in and square and add 9 to it and get 0, which means no, I don't have any vertical asymptotes. There are none, okay? And I kind of purposely did that so you would look at that so I could address it here. And my horizontal asymptote, I can see I have a degree 1 on the top, a degree 2 on the bottom. Therefore, if the top is smaller than the bottom, y equals 0 is my horizontal asymptote. And the very last one, well, my denominator doesn't factor, but 4 does make the denominator 0, which means 4 is my vertical asymptote. And here I can see the degree of the top is bigger than the degree of the bottom, and whenever that happens, we will not have a horizontal asymptote, all right? So what we're going to do here in our next problem, it's really not as much group exploration. We've already talked about this hole in my function back in section 11.2 briefly, okay? And I'm going to follow through a 6-step process, but I'm going to kind of modify my 6-step process here. And when I do this, what happened at x equals 2? Well, we're going to see what's going on. Well, the first thing I'm ever going to do when I am graphing a rational function is I'm going to completely factor my function. So x plus 2 times x minus 2, because that's the difference of squares down there. And right after I completely factor this little bugger, what I'm going to automatically do is I'm going to state my domain. What values for x make my denominator 0? And that's my domain's going to be all real numbers x except -2 or 2, because either positive or -2 will make that. Well, then I notice something weird's going on here. I have a common factor in the top and the bottom, so I'm going to reduce that common factor, and I'm going to get the green light to continue factoring my x plus 2 here. All right? So now I'm going to look at my reduced fraction to find vertical asymptotes, because just because it's a restriction does not mean that it is going to be a vertical asymptote. I only have a vertical asymptote here at x equals -2. And so I'm going to graph that vertical asymptote at x equals -2. And you might be saying, okay, well, what's going on at that +2? Well, and I'm going to try to get down here, and we're going to have what happened at x equals 2. There's a hole at x equals 2. There's a hole here. Okay, and how do we find our hole? Well, we're going to kind of plot and graph our hole. So I got to come back, and well, what happens if I put a 2 into my function? Well, I want to put that 2 into my reduced function here, because then I can see my hole is going to be at 2, 1/4. And that is precisely the location of that hole. And I'm going to go graph that hole over here over 2. And then I'm going to go up 1/4, so over 2 up 1/4. So I'm going to make a little hole right about there. I'm going to graph that little bugger. Now I'm going to look for my horizontal asymptote. Now I'm looking for my horizontal asymptote either here, but typically I want to look for it over here. And I can see I'm going to have a degree 0 on the top, a degree 1 on the bottom. So that means the degree on the top is smaller than the bottom. So I'm going to have a horizontal asymptote at y equals 0. So I'm going to graph my horizontal asymptote at y equals 0. And I'm going to boogie that little bugger over there. I always find my y-intercepts. Okay, I don't care if they're on your instructions or not. You should always be finding a y-intercept because they're really easy, because it's 0, what? Well, I'm going to, because my function reduced, every value for x I'm plugging into my reduced function. And if I put 0 into that function, I get 0, 1/2, right? So I'm going to graph that 0, 1/2. It's a little bit higher than my hole is. The other thing I want to do is I want to find my x-intercepts. And of course, I'm going to look for my x-intercepts where the numerator equals 0. But because I reduced my fraction, all my points are coming from that reduced fraction. And is there any way to make that numerator into 0? And the answer is no, so there are none. Okay, I don't have any horizontal or any x-intercepts. And I'm only going to plot a few points if I need to plot a few points. Okay, well, I already know this portion of my graph is going to be right here because my points are up there. And I also know that because this is not to a power, my denominator is not to a power of 2 or an even power, I also know that I'm going to be kitty corner. And if you're like, what are you talking about, Kruger? What do you mean kitty corner? Well, if you're not picking up what I'm putting down, then what I'm going to do is I'm going to make a quick little XY chart, because I'm assuming plotting a few more points. I'm going to pick another point on the left side of my vertical asymptote, so I'm going to chuck a -3 in there. And if I put -3, remember, I'm putting it into
my reduced function. If I put a -3 in there, I get 1 over -1, and I get -1. So I'm going to come over 3, down 1, and I can see here is my graph, and that is my graph. And notice this graph has a hole precisely at 2, 1/4, all right? And that's how we find a hole in my function, dear Liza. And basically, that's exactly what this is. And what we're calling that hole in upper level math is called a removable discontinuity. Because in math, when you hit calculus and beyond, we're going to find a way to plug that hole to make our function continuous, but a vertical asymptote would be called a non-removable discontinuity, and that discontinuity just means there's a break in the graph at that point, okay? And that removable one you'll be able to plug later on, but we're not plugging those this year. So let's try another one here really quick. All I'm going to do is 2 more, and I'm going to do 1 more with you, and after I do that one with you, I'm going to have you try the last one on your own, all right? So what we're going to do is, first step is, I highly recommend you completely factor both numerator and denominator of your rational function. And this is going to give me here and here, and that's going to give me an x and an x. My signs have to be opposites, and I need more positives, then I need negatives, and then I'm going to state my domain. My domain is going to be all real numbers, x, except -4 and 2. Because those 2 values make my denominator 0. The next thing I'm going to look at is my eyes instantly gravitated to these 2 factors that are going to reduce. And because that factor reduced, a factor with x in it reduced, that domain exclusion of -4, it is no longer a vertical asymptote. I'm going to have a hole at x equals -4. And how do I find my hole? Well, I'm going to find the hole by, after I reduce this, I'm going to get the green light to evaluate my function at my reduced equation of 3 over x minus 2. And I know my hole is going to be at -4 comma what? Well, if I put -4 into my reduced function here, I get 3 over -6, which is going to give me what? -1/2, I do believe, no wait, 3 over -6. So yeah, I think, or am I doing that wrong? Hold on, Kirby's got to focus a second. Kind of losing my marbles for a second, but I did some pretty sound math. So I have a hole at -4 comma -1/2. I'm going to go graph the hole. And how do you graph a hole? Well, you go over -4. You go down -1/2, 1, 2, 3, and you make a little circle where that hole is going to be. Now I'm back off to the races, because now my vertical asymptotes are only when my reduced function will equal 0. So I have a vertical asymptote at x equals 2, and I'm going to graph that little bugger at x equals 2. So that's right there. And then I'm off to the races to find my horizontal asymptote. I'm going to find and graph that bugger. I'm going to look up here again, and I can see the degree of the top is 0, degree of the bottom is 1. Degree in the top is smaller than the bottom, so I have a horizontal asymptote at y equals 0. I am precisely going to graph that. Notice, if you don't graph your asymptotes, that's a grading point we're going to have for you guys on your summative, just like we did on your formative. You need to graph your asymptotes. They're very important. Beyond there, some of the best sketching tools we can graph are y-intercepts and x-intercepts. Well, y-intercept is whenever I plug 0 in, and remember, if it reduced, we are finding any points, and we're finding them in our reduced function, so that if I plug 0 in there, I get -3 over 2, right? Well, that's 0 comma -1/2, so that's about right here. And I'm going to find my x-intercepts. Well, my x-intercepts happen when my reduced numerator equals 0. And is there any way to make the numerator of that fraction 0? And in this answer, there's none. There's none because I can't make 3 into 0 because there's no variable to plug in up there. So now I'm going to come back and I'm going to do my graph, and I'm going to do the best I can. And I'm definitely going to make sure I go through the points I found. Notice I picked up my pencil and I didn't make my graph go through a solid line through that hole because it's a hole. It stops and then it starts on one side and the other side of -4. Then remember, there's a piece of your graph that is on both sides of all vertical asymptotes. So I need to say x, y. And I need to know, well, where is it on the right side? So I'm going to plug a 3 in there. And if I plug a 3 into my original function, I get 3 over 3 minus 2. I get 3 over 1, or 3. So I'm going to go over to my point, over 3, up 3. I'm going to make a point. Oh, I know where my branch is, so it's coming through here. And I have that little bugger graph. And that's all there is to it with holes, all right? So what I'd like you to do is I'd like you to do number 2 quick, and I'm just gonna hit pause, and then I'm gonna have the answer back here for you. But if you do it the same process I just did, you won't get them wrong. All right, so if you're back for the attack, you see the first thing I did here, number 1. Number 1 was I factored my polynomial. And as soon as I factor it, technically the second thing I did was I stated my domain. Okay, the third thing I did is because that x there reduced out. Number 3, what I did here was I stated I had a hole at x equals 0 because that was my removable discontinuity there that I took out. And then I found my hole by plugging 0 into my reduced function. And I found my hole and I plotted the hole. Then from there I came back and I proceeded to do my vertical asymptotes, technically number 4, and I graphed my vertical asymptote at -3 because my reduced function still had a -3 in it that made it undefined. Number 5, the second thing I did was I found my horizontal asymptote off of my reduced function again, and I could see the top was smaller than the bottom as far as powers of x, so it was y equals 0. The sixth thing I did was I looked for my y-intercept, and I almost fell in. I'm like 0, comma, and then I put up there, I'm like 2, and I don't really have a y-intercept at 0, comma 2 because there's a hole there, so I never intersect the y-axis. Ooh, kind of a crafty one. And then seventh thing I did was I looked up here, I'm like, hey, there's no way to make my reduced function, the numerator of that reduced function, equal to 0, so I don't have any x-intercepts. And then I came over here and I graphed my branch on the right side that went through that hole over there. And I'm like, well, I knew it was down kitty corner in the bottom, but most of you probably don't yet. So what I did was I graphed -4. I plugged the -4 because that's on the other side of the asymptote. I plugged it in. I got -6. I found that point, and I just made my graph. You don't have to find a ton of points. We are graphing that you are plotting your vertical asymptote correctly, your horizontal asymptote correctly, your x-intercepts and your y-intercepts correctly if they have them, and then are your branches in the appropriate spots. So the last slide I'm going to show you here, guys, is Kruger's fail-safe rules to graph any rational function. These are not in your notes, but if you follow this, they're really hard to graph wrong. First thing is completely factor your rational function, both numerator and denominator. Then you focus on the denominator and state your domain exclusions, okay, like we've been doing. Second thing I'm going to do is I'm going to reduce that rational function. In any factor with an x in it that reduces out, it's going to be a hole in your function. So that's why I find my holes right away. And you find your hole by plugging that value for x that reduced out into your reduced function. That gives you the precise location of the hole. Then I find my vertical asymptotes and graph them. Then I find and graph my horizontal asymptotes and graph them. Remember, here are your rules. Technically, the top 3 are your rules for horizontal asymptotes. And sometimes, if you do not have a horizontal asymptote, many times you have a slant if the top's exactly one more than the bottom. Graph those little buggers. Then I find my y-intercept if I have it, and I find that by plugging 0 in for all the x's. Then I next find my x-intercepts if I have any. And that happens when the numerator of the reduced function equals 0. And then number 9, I only do if I need to, okay? And remember, if you need more points to complete your graph, there is a section of graph between and beyond all vertical asymptotes. And if your function reduced, make sure you're finding these points in the reduced function. The mathematics are going to be easier to find there, okay? Kruger's fail-safe rules of graphing a rational function, step-by-step instructions. You can't get them wrong. And all we're going to ask you to do tonight are numbers 1 through 3 on your 11-4 try on your own. They may not have holes in them. So follow these rules I gave you right back here, and you will be golden. And we will finish up a couple more tomorrow yet. Have a great rest of your day.